to the third power. There is a formula for it, but I don't want to overwhelm you. There is no need to remember this one at all. But you have to remember that this is x plus 3 times x plus 3 squared. And this we know. Please do not FOIL this. If we still FOIL x plus 3 squared, we're going backwards, not forward. The first term squared plus 2 times the first times the second plus the second term squared. First term squared plus 2 times the first times the second plus the second term squared. Okay? Now write them side by side. And now we use the distributive law again. So x times x squared, x to the third, x times 6x, 6x squared, x times 9, 9x, 3 times x squared, 3x squared, 3 times 6x, 18x, 3 times 9, 27. So again, when I have x plus 3 to the third power, yes, we have formulas for this. We can also use something called Pascal's triangle. No need, no need. So you just write it as x plus 3 times x plus 3 squared, copy the base, add the exponents. We get 3. Raise the binomial squared because we know the special product. And then write them side by side and continue distributing normally. A binomial times a trinomial. Yes, we haven't finished because we have to combine like terms. Always the degree first. And then I have 9x squared. And then I have plus 27x and then plus 27. I want to draw your attention to something that you should remember. It's very important and it's not difficult to remember. See, this is a binomial to the third power. We know that a binomial to the second power is a trinomial, meaning a binomial squared is 3 terms. A binomial cubed is 4 terms. Always one more than the power. So if I were given x plus 3 to the 10th power, I know now that I would have come up with 11 terms. Always one more than the power, if it's a binomial. So a binomial to any power, when I expanded, I will get one more than the number of terms is exactly one more than the power we raised the binomial to. So remember, that's why when we had power 2, we got 3 terms. When we had power 3, we got 4 terms. One more than the power. And again, allow me to say that this will be an absolute terrible mistake to write x to the third plus 27. This is a terrible mistake. Never, never, ever, ever, never. No. Do not confuse the binomial to some power to 3 times x to the third power, which is indeed 27x cubed. This is an exponential rule, but this is not an exponential rule because these are terms, not factors. Okay. Good. Going back. So here we have to write 4 terms. Exactly what we obtained. X to the third plus 9x squared plus 27x plus 27. Okay, let's see what else is in here. Same thing. I have 2 options here. And I want to show you the 2 options. You can just use this special product on x plus 3 and then distribute x minus 3. So that's fine. That's perfect. But I want to show you something else with this problem. X minus 3, x plus 3 squared. I'm checking for a second to see if I can eliminate those videos from the previous class. Yes, I can eliminate all of them. So, because I don't want to worry about not being able to record your lesson. 1, 2, 3, 4, and 5. Okay, they're gone. There is enough room on the hard drive now. Okay. So of course, option number 1 will be x minus 3, and then you expand the first term squared plus 2 times the first times the second plus the second term squared, and you proceed. Exactly as we did with x plus 3 to the third, similar. But let me show you a second option. It doesn't matter which one you use, but I just want you to point out something here. When I look at this example or this problem, this is what I see, which is correct. The x minus 3 and then x plus 3 times x plus 3. I can perform this, which is much easier. First term squared minus second term squared, x squared minus 9. And now when I multiply, it could be somewhat shorter. It doesn't matter. I just want you to see a second option. Regardless of which one you use, the answer must be the same. So I could have used the special product for a binomial squared. Or if I write the whole thing out, I could have used the special product, which is the difference of perfect squares.
Can we keep going with option 2?
Yeah, yes, of course. So with the option 2, I would say it's even shorter because I have two binomials instead of a binomial times a trinomial. But it doesn't matter. The answer will be the same. And you can start from the left or start from the right. If you want to start from the right, you will say x times x squared, which is x cubed, x times negative 9, which is negative 9x, 3 times x squared, which is 3x squared, and 3 times negative 9, which is negative 27. Yes, it has to be arranged in descending order. So I have x cubed minus 3x squared minus 9x minus 27. I'm sorry, this is plus. So it's important to see things that we learned. That was the whole purpose of me showing you the other option. But of course, it's not a big deal. It's not a huge difference by any means. Okay, let's see, 15. Okay, so this is a good one. Why? Because 4x plus 3 and 4x minus 3 is exactly the first special product we looked at, which is the special product called the difference of perfect squares, or difference of squares. A plus b times a minus b. And I know the answer is right away. Again, foiling this, I cannot stress enough, is going back in algebra, not moving forward. First term squared minus second term squared. So this is 16x squared minus 9. And look how nice. Now this is the same special product because the terms are the same and the last terms are the same. So all I have to do is square 16 x squared and minus 9 squared. Again, foiling will not be good. Please. I'm not saying it will not be correct. It will be correct, but moving forward. Not moving forward, but moving backwards. So 256x to the fourth minus 81. So we were able to do all this in a blink because we knew the pattern and we knew the special product. Otherwise, you will have to work much harder to come up with the correct answer.
Is there a way to verify that easily?
To verify it,
Yeah. If you forgot the special ones.
you can, but please don't resist the special product, because when we get to mod 6, that will be a tragedy. Yeah. I don't want to sound like a drama queen, but it's really important. I see it in Calc 2 even. Students have difficulties with this because nobody insisted maybe, or maybe nobody taught them, or they forgot, who knows. Now let's work on this one for a minute on our own. Please use the special product on P minus 4 and then distribute 4P. Remember, you have to address the power first. I've seen it, and even Calc 1 and Calc 2, students distribute 4P first and then square. That is not possible. By the order of operations, we have to square first and then distribute 4P. The reason why I insist and insist and insist is because this is the first and the basic course in the STEM sequence. A student struggling in this class may continue struggling in the next and the next and the next and the next. And I don't want that to happen to anyone. I know I sound like a broken record. I apologize. So say it like a tune, or put a tune to it. First term squared minus 2 times the first times the second plus the second term squared. And only then distribute the
4P?
the 4P. Yes,
Okay.
the monomial, always. Because you can't, you're not allowed to distribute it before you square. So we have 4P outside. First term squared minus 2 times the first times the second. What is it?
Minus 8P.
Yes, plus the second term squared.
60.
Yes. Only now distribute 4P. And you get 4P to the third. You get minus 32P. And you get plus 60, P squared, sorry, plus 64P. Trinomial in descending order, degree 3. Leading term 4P cubed. Leading coefficient 4. Any questions on this? Any questions? Anybody? Any questions? Okay, so let's continue then. So let's see, 17. Yes, let's work on 17. Because now it has a little bit more complicated situation, a little bit more work. I wouldn't say more complicated, but it requires a little bit more work. So let's copy this. N plus 3 times n minus 3 plus n plus 3 squared. And then I will show you an alternative. So 1 minute. Let's work on this problem. N plus 3 times n minus 3 plus everything in parentheses n plus 3 squared. Let's work on this for a minute. What you hear, I'm putting in your attendance. That's what I'm doing in the background. Because I have to enter it after each class. And then I would like to show you something on this problem, because I want to prepare you for Mod 6. Do we need more time? Do we need more time on this? Okay, so one option number one, is to multiply. I know the rule. The terms are the same, so it's n squared minus 9. I know the special product, n squared plus 2 times the first times the second, plus the second term squared. Now I combine like terms. I have 2n squared plus 6n. All perfect, no problem. And this is it. But I want to show you something else, because we're going to need this procedure. N plus 3, n minus 3, plus n plus 3 squared. So there are two important concepts here. One is distributing. The other concept is factoring. When we distribute, we get terms as a result. When we factor, we get factors as a result. This is more valuable, more applications, more valuable than terms. Terms are good, but we can do more with expressions that are fully factored. We can solve equations. We can simplify. This, moving forward, I always tell my students, don't do anything. Don't do anything before you factor and simplify. These are two key words in math forever and ever. So that's why this is so important. Distributing is very important, but terms are not that good. Factors are. I can simplify. I can solve equations, yada, 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 on and on and on, which terms do not allow. So, keeping in mind, when I'm looking at this, I see two terms. This is one term plus, here's the second term. Terms, although you can say, but these don't look like terms. I understand. I agree with you. They don't. But these are two, where are my props? These are two quantities that are added. That's what I mean. Two quantities that are added, but they have a common factor. And the common factor, I'm jumping over all this. The common factor is n plus 3. Since I have two quantities, I have to have two quantities inside, one coming from the first one and the other one coming from the second. What is left from the first one? If I took n plus 3 out, n minus 3 is left. Plus, when I took an n plus 3 out, there is an n plus 3 left. So n minus 3 is left from the first quantity when I pulled out n plus 3. And another n plus 3 is left from the second quantity because I pulled out an n plus 3. And look here. So all I have is n plus 3 multiplied by 2n, which is, when I distribute, 2n squared plus 6n. Now, this is perfect. but this is way more valuable than this. Because this is in factor form. What factor form? 2n plus 3. This form of the same expression is way more valuable than this one. If I need to solve equations or simplify expression, this is the one I need, not this. Okay, we're going to see the factoring, as I mentioned. Did everyone get that email? If you did not get the email or you cannot open the files that I attached, they are found also